Okay, so this is a video from Math 102. It's about using Excel to get regression lines, other lines, and also residual plots. So let's start off with the following. We have some Math 102 height versus weight data, and we are currently using height to predict weight. So here is the corresponding scatter plot, height on the x-axis, weight on the y-axis. And you can see the averages. Right, so here's the summary. We see a relatively strong correlation of 0.6. And you can definitely see this sort of nice trend going on here. So to get a regression line in Excel, you have to press, well, if you're on a Mac, you press Control, Shift, and click on the data at the same time. A menu comes up, you add a trend line. On a PC, you just right-click and the same menu comes up. There are lots of different types. We're going to stick with linear, and it's important to go to the options and display the equation on the chart. Okay, you can change the color of the line, you can move the equation around so that you can actually see it. I find that's very helpful. And of course you can change the font size, which maybe I will do so that you, the viewer, can actually see this. Alright, so that's easy peasy your regression line. If you use Google Docs spreadsheet, you can't ask it to make a regression line. So sometimes it's very useful to fool the program into sticking a line in on your data, and we're going to do that in a moment. But of course, we also know that one way to tell if regression lines are good versus some of those other formats is to make a residual plot. So, to make a residual plot, make a column titled residual and another one titled baseline. So the residual is the data value minus the predicted data value. Now, because we already have the regression line in this case, to get that difference, sorry, my mouse is missing. Ah, there's my mouse. Okay, so to get the difference, we would choose our y value, weight, and we would subtract the value that we get from the regression line. Now, there's not a whole column of data from the regression line. However, we can plug that in because we have the formula. Now, you don't remember the formula, but we saw it before. It was 5.7383 times the x value, which is height, and then minus 236.63. So it's just the equation of the regression line. And there we have it. The residual is minus 10, meaning that the actual weight was 10 below the predicted weight. And we extend this all the way down our data set. And that's our predictions. And of course we want a baseline. So we get a couple in there, and then we extend that all the way up. There we go. Okay, so this is all of the information we need. We go to charts and insert another scatter plot. I like it when they come up blank. You can select data as you choose. I'm going to add two series. One series is the residuals. Now the residuals have an x value, same as your original plot, so height. Now height goes all the way down to 128, so I'm just going to type 128 in the box. There we have it. The y value is the residuals that we just calculated. And again, that goes down to 128. Okay, so that's one of our series. But we need another series, the baseline series. If I could spell, there we go. Same x values. Now the y values are all zeros. This baseline. And we're good to go. Of course, everything looks all smushed and funny, so we better change that scale. I think 55 is a good minimum for the height. Possibly 60, we can see that. Okay, So the blue dots are the residuals, the red dots are the baseline. Let's make this a little bit bigger. And that looks messy. So to make it look nicer, we're going to turn this collection of red dots into a real line, and then we're going to make the red dots go away. So to turn it into a line, we make the regression line. Now it's not the regression on the original data, it's the line that best fits the baseline. It looks pretty straight, so it makes sense Excel's going to spit out a straight line. So I'm on a Mac, I'm going to press Control Shift and then click on the red data points, add a trend line. Now this time I don't want the formula to appear. The formula better be y equals 0. Okay, so there's the line. Now I need to get the dots gone. So if I double click on the dots, choose marker style, and instead of automatic, no marker, they're gone. So you can, play with this a little more. Maybe I should make it 60 so you can really see a little clearer. There we go. We've got this nice line here. That's the baseline, the solid residual line. And we're looking. Do you see any sort of general trend? Does it look like a parabola smiling or frowning at you? Do you see anything going up? No. It's a nice cloud around the baseline, so linear seems to be a pretty good model. Of course, you should label your axes, label the graph, but we're on a mission today, so some other time you can do that. After moving that out of the way. Totally out of the way. There we go. Okay, so the other task that we have for us today is, what if you are on a computer that doesn't let you plot the baseline right away? Or what if you want something besides the regression line? What if you need a different kind of line? So here's our scatter plot. We're going to fool Excel. We're going to plot points that should be on the regression line. Now, we know the formula for the regression line. We worked that out in class. You have that on your formula sheet for the exam. So here's the formula for the regression line. We've got the ratio of the standard deviations times that correlation times the difference between the x values and the average of x plus the average of y. Now, on your next computer assignment, you're going to be using a different line for predictions, the bottom line. Notice that there's no correlation coefficient included. So I don't want to do your homework for you. Instead, I'm going to show you how to make the regression line, and you're going to make the appropriate changes. Okay, so we just saw that line. We know we need the ratio of the standard deviation, so let's put in a cell that's actually standard deviation of y divided by standard deviation of x. That's going to save us a little bit of effort later on. So here's my y standard deviation. I'm going to divide that by my x standard deviation. And don't forget that is cell P26. Okay, now here's our data. I'm going to start off by doing the stuff in parentheses. So that's the x value minus the average of the x. So x is the heights. I'm going to subtract off the average of the x. Now the average of the x is in cell L20 something. Oh, I think it's L26. Hold on, let me see. L26. So now, if I just drag this down, weird things happen. Because as I move down, see, it's not L26 anymore. Now we've got L33, a cell we don't care about. So I want to make sure that L26 is fixed in all of the formulas. I'm going to put dollar signs around the L. This time when I drag, I have reasonable numbers, and you can see the 26 is still there. So I have to drag this all the way down. It seems like towards infinity, but I only get up to 128. Okay, so that's the intermediate step. A bunch of cells with x minus x ab. That's the stuff that we typically see in parentheses. So to get the y hat, to get the regression line, we take the stuff in parentheses and we multiply it by the ratio of standard deviations. So that's P 26. Now I want that to be fixed throughout, so I've put dollar signs around the P. And then we multiply by the correlation coefficient, which in this case is M28. Right? Now there aren't dollar signs, so I better put those in manually. There we go. So that's the product, right? We've got our coefficient, the ratio of standard deviations, we've got the correlation, and then we have that difference, x minus xf. But don't forget to add on the average of y's, and the average for y here is 156 point something something something. We want that also to be fixed. So, now, what we have is, for height of 63.5 inches, the regression line would estimate a weight of 127.75 inches. The actual weight is 117.5. Okay, better drag those down all the way too. Okay, so really the only column I care about is the y hat column. And if you want to stick the formula in all at once, you can do that too. But I find making this x minus xav column kind of a useful intermediate step. It's up to you. Alright, so now I want to put this on my scatter plot. Fortunately, I already have a scatter plot. So let's go to select and add more data. So my new series is going to be regression line. The x values are the same x values we've been using all along, the height, and that goes to cell 128. Okay, but now the y values are my y hats. Okay, looks pretty linear, nice and interesting. I'm going to do the same thing that I did with the residual plot. First, I am going to force Excel to add a trend line. Since it's adding a trend line to something that looks linear, it's basically just making the line that fits that data. Options, display equation on the chart. Now, I'm going to move this out of the way. Oh, you can't see what I've been doing. Sorry about that. I hope you can survive. Most of what I've been doing was still visible. I'm going to make this bigger so you can actually see. Look, it's the same equation that we had at the beginning. Now, of course, I'm not done. Double click on these. Change the marker type to no marker. And ta-da. Now, just in case, if you don't believe me, you could click on your data, press Control and Shift and click, or right click on a PC, add a regression line, and you'd see we have some nice looking, it really is the regression line. Of course, on your homework, you're not making the regression line. You're making a line that people used to use for predictions. Before correlation was around, before people figured out a way to incorporate strength into their ideas. So you're going a little historical, and Excel won't make that for you automatically. So you'll have to try something like this. Good luck, have fun, write everything up beautifully, you'll do great. Good luck.